So here to begin with our substitution, I like to pick W. You can pick another letter if you want. But let's see. So the nested function is the one that is most deeply within. Here I would argue that 3 minus x would be a good representative for W. Now, what would dW be? That would be, well, the derivative of 3 is just 0. The derivative of negative x would be negative 1 times dx. And let's see, so instead of all x's, we want all w's. So let's see, so let's try this now. The 8 can go out to the front, just squeeze it in right there. Now I need something that replaces x, but I don't have x isolated anywhere unless you manipulate this equation. You see, if I add the x to the left and subtract w to the right, that would say that x equals 3 minus w. You see what I'm saying? And that's necessary because over here, instead of x there, I can write 3 minus w in parentheses. And then we keep natural log, but instead of 3 minus x, we can just put w. And instead of dx, we have, how about I kick the negative to that side? That'll be negative dw equals positive dx. So as we were, instead of dx, we have negative w, negative dw. So look, I'll put the dw there and I'll put the negative in the front with the 8. So we have negative 8 integral 3 minus w ln w dw. So the substitution turned everything from x's into everything with w's. What if we distribute the natural log of w? So that would equal negative 8 integral. Then we'd have 3 ln w minus w ln w. All of that is dw. And what we can do is we can actually separate this integral into two smaller integrals. So the negative 8 is still out there, then some brackets. So that one integral broke up into two different integrals. And the reason I did that is so I can focus on an integral with just one term. Instead of an integral with two terms, I'd rather have two integrals with just one piece. I think that they're easier to attack that way. So our substitution is set. Now we need our parts integration, but you know what? Since we have two integrals, we might need two sets of parts. What if we do this guy? Let's just do it up there, and then this piece, we'll do it down there, and then we'll go from there. So up here for this one, I need my dw goes for the dv. Now, usually I have like two functions. Like here, there's two functions, but in this one, there's only one function, unless you think of the number 1. So I put a 1 so that I have two things. I have 1, and then I have ln w. One of them is going here, and the other is going there. Let me tell you why I'm not going to put 1 right there. If I put a 1 right here, then I'd put the natural log of w there. But I don't know what the antiderivative of this is to go backwards, so that's no good. And furthermore, if this is 1, then this would be 0, the derivative, and that doesn't help either. So I'm actually going to put ln of w here. ln, that's natural log of w there. And just the 1 is just going to go here, okay? Now, this is not too bad because the derivative of u du, the derivative of natural log of w is 1 over w dw. And if this is dv, then the antiderivative would be w because the derivative of w is 1 dw. So right now we are only going to focus on the orange stuff. And based on parts integration, the stuff in orange gets replaced by this. uv minus integral v du. So I have u and v minus integral v du. Well, look at this product. When you multiply v and du, when you multiply w and 1 over w, they're gone. So it's just dw. Okay, and then minus. And then why don't we now attack this second orange piece, which is coming from here. So let's set this up. So now let's focus on that and that here, right? So we have two different integration by parts going. So we know that dw goes down there. Now we have two functions, w versus ln w. One of those functions goes here and the other goes there. So now between these two, I propose that ln of w should be placed there, and then w should be placed here. And I'll tell you why. Because if I had placed ln of w there, I would not have known its antiderivative. But since I put it there, I know that the derivative of ln of w is 1 over w dw. And here, backwards, if this is dv, w, then here I need something that the derivative of that gives me back this. Well, that's the antiderivative of w, which is 1/2 w squared. Because if I take this derivative, I get exactly this much here. So now let's rewrite this double orange stuff by using this parts integration. uv minus integral v du. So we have minuses there. Then we have uv minus integral v du. So if you multiply this with that, and if you simplify, it's going to be 1/2 w dw, because the square knocks out the one from the bottom. There's only a single w left. So 1/2 w dw. 1/2 w dw. Let me close bracket. So now I think we're ready to finish this. Let's just rewrite this. So let me explain what I did. Everything stayed the same except for this. The antiderivative of 1 dw is just w. That stayed, that stayed. Here I took out the 1/2 to the front. So now the antiderivative of w is, of course, 1/2 w squared. So let's make that change. So let's see. So the negative 1/2 was there. And then the antiderivative here of w is 1/2 w squared. Keep the plus c if you want to. Now, I don't think anything can be combined here. Let's simplify this a little bit. Let's see, so a few things happened here. I combined like terms, or I grouped terms accordingly. That stayed. And then I put this one after it because they have an ln w in common. That negative w, I sort of kicked it toward the back. And then from these two terms, I factored out a w, ln w, and from these two terms, I took out a negative w. That's how I went from like here all the way to down here. This algebra, very often professors do want students to do that. So it's good to know this. Now, for the final answer, just write this all over again, but instead of all of these w's, we write 3 minus x, because remember, the problem began with x, so it should finish with x. So let's make that change. So again, I made up this problem. I made it worse than what yours is, so my answer is a little more dramatic than yours, but follow this same idea, the same routine. Allow w to equal whatever embedded function you have, and then all in terms of w's. At some point, you might have to use 1 or 2 sets of parts substitutions, and at the very end, bring it back in terms of the same variable that you happened to begin with. So here we are, final answer.